The Model 12, fully aerobatic capable biplane, now produced by 92nd West Aviation in the little town of Lone Oak, Arkansas. Originally designed by Curtis Pitts and then later refined by Jim Kimball Enterprises. 92nd West Aviation has taken the reins and owns the rights to this beautiful design and now offers plans, kits, components, and even a builder assist program. Follow along as we dive deep into the construction details of the Model 12 aircraft.
My name is Don Adamson, and we're at my hangar at the North Little Rock Airport, and I build Pitts Model 12s. We bought the company from the Jim Kimball Enterprises and Kevin Kimball about 4 years ago, and we've started producing or continued the production of the kits of the Pitts Model 12.
All right, Don, so just for anybody who's brand new to the Model 12, explain what exactly is it? Is it a one-seater or two-seater? Is it what is the basics of it?
Yeah, so the Pitts Model 12 was the latest from Curtis Pitts. Well, we call it the best one that Curtis Pitts ever designed. And it's a two-seat aerobatic biplane, and it was designed around a Russian, well, can't say Russian anymore, the Romanian M14P radial engine. And the engine stock makes about 360 horsepower. The airplane is about, I guess we're about 24-foot wingspan, 22 foot is the version we build. And anyway, it's very aerobatic, and it's also a good cross-country, you know, has a lot of speed, 170 mile per hour cruise airplane. All
right, Don, so this is a radial engine is pretty much the only engine option at the moment with this, and that's how many horsepower?
Its stock is 360, and they've been hot rodded up to almost 450 horsepower now by changing pistons, compression ratios of the pistons, blower compression ratios, and ignition timing, fuel injection, and anyway, so they've been able to squeeze about another 90 horsepower out of the engine reliably, and which is another thing. And they're able to turn a 102-inch MT propeller with that engine, and they do it through a reduction gear drive that's built into the engine. And that combination of power, I guess, adaptability gives the airplane the ability to do some of the things that it can do that other airplanes can't because of the power to weight ratios and the thrust ratio that's available from that engine propeller combination.
So the other engine I'm aware of that has a reduction drive on a radial is a Rotec, and that's kind of what's the exact term for that type of gearbox?
Planetary drive gearbox is what we use, and the M14 uses. So it has a shaft that goes in, and 3 or 6 in this case spur gears or outer gears driving another shaft at a ratio of about 0.6 to 1. I think it's 0.647 exactly.
So that configuration, the crankshaft is still in line with the prop shaft?
Yeah.
Being that it is a gear reduction, what is the engine RPM at max horsepower versus the prop RPM?
So basically the engine's turning around 2,700 RPM and the prop is around 2,000, 2,100. I mean, we could figure out exact numbers, but in basics that's about what it is. The 2,000 RPM keeps the tip speed down below supersonic, which is a very important thing on a propeller, so that it doesn't become toothpicks and start to destruct itself if it goes supersonic.
Supersonic. It's quite amazing to think that your propeller tips travel that fast, but they can and will if you're not careful with your engineering. If you are enjoying this video so far, engage that like button and leave us a few comments below. We love the aviation conversation. All right, so going back to the airframe for a minute, Don, what is the materials used to build the entire airframe?
Okay, so the Model 12, the fuselage is constructed of 4130 steel. It's tubing. It's American sourced. We cut some of the parts on a mill, and some of the other parts are cut on a Campbell nibbler, which is from, I believe, the 1940s. We have it at the other shop, and we have little jigs and dies that will nibble the shape of the coping of the tubes, and then we have another jig that we'll assemble all this stuff into, and then go and weld up all the fixtures. This here was a one that we built with the Campbell nibbler and our own milling machines. We have since hired VR3 out of Canada to build us a tubing kit in which they cope all the tubes with a laser and a tool post grinder. And out of VR3, the tubes all fit within 5/1000ths of an inch. And so we can build the fuselage without a jig. We use a flat table, and we have a couple of fixtures to hold everything square, but once we've squared it up, it pretty much will hold itself together with bungee cords.
So let's talk about the canopy area and turtle deck construction.
Yeah, so this one here, we have the open cockpit version, and the frame itself is built out of 4130 tubes. These we hand frame because of the curving and the bending required. We do have a fixture for welding it all together, but we hand form all of these curves and bends. We use aluminum. We pop rivet the aluminum on the side skins. Now the turtle deck is it's all built out of aluminum. We have the bulkheads are laser cut, and then we'll hand form the edges on them, and then we'll attach it to a frame and rivet it together. Now this one was pop riveted. We've since gone to driven rivets on these just because I like them better, and we know how to fabricate with driven rivets. I built a few RVs before this. But one of the things we do on our is the middle bulkhead is bonded in. So if you'll look inside there, you'll see we use 2216 glue, 3M 2216 epoxy to bond the center bulkhead in, and then that way we don't have any rivet lines or dents on the outside of the aluminum. It's nice and smooth. All we have is the ones at the front and the back, and then those are easily covered when we do our fabric process. But there's no dents to fill in the middle because we bonded the middle.
Tricks of the trade.
Yeah, it's stuff well, I didn't come up with this, I just copied it. So, and it's just been applied to this application.
We are partnering with great companies like Dynon Avionics at Dynon.com, Airtech Coatings at AirTechCoatings.com, AviNation Youth Magazine at AviNationUSA.com, The Aviators Clinic at AviatorsClinic.com. Take a moment to go visit their websites at the links found below in the description of this video. And visit our website at ExperimentalAircraftChannel.com for events, our video library arranged in easy-to-find playlists on specific topics, affiliate products, aviation merchandise, and so much more. All right, moving over to the wings and the wing construction. Tell us about how they're constructed and the materials used.
Okay, so our wings are wood wings. We use a combination of Douglas fir for the spars and spruce for the rib construction, and some of the filler materials we use spruce and other woods, and then there's plywood used on the nose rib to create this. These are a kit rib, and so all the wood is cut in a CNC router, and so it's perfect. They're all the same. Each one matches. The holes all match, and it's just a matter of gluing together the big model airplane wing. Douglas fir was chosen because of the added strength. Yes, it does. It's a little heavier, but it also gives us an added strength for the thickness that we have to work with for spars, and it allows us to be in the aerobatic category with a wood wing.
Now, how do you go through the process of building the ribs built up on a separate jig, all of them, and then slid down a spar, or how is this built up?
Yeah, so we build the ribs on on jigs, we have some jigs there in the back that are routed out of particle board, and that's all CNC routed the same thing, and we have instructions to show you how to place the nose rib in it, place the sticks to build the rib, and then where to put the gussets, and then we use T88. Other people use the West System type glue or epoxy glue, and then so we'll put the gusset on, and then we'll drive a staple in to hold the gusset while it dries. We leave the staples in. I don't think we're increasing the weight that much, and they don't provide anything other than holding the gusset in place while the glue dries. They're not designed to provide anything other than that. Once all the ribs are built, then they are slid onto the spars. The uppers are a little more challenging because in the middle we have a spar joint where the wing takes a transition from being straight to swept back, the spar. So there's a transition joint in here where we have different pieces of wood and fillers, and then it gets boxed with a piece of plywood or with plywood, and then all T88'd. And then eventually, and then at the end, we'll put a 4130 steel bracket on here that ties the wing to the fuselage. This wing is upside down at this point. And then these will get bolted in, and there'll be some more flying wires and stuff. The dimension of the wing is held, or the, I guess, yeah, straightness of the wing is held together with these stainless wires. We call them drag and anti-drag wires. Right now these are not connected up. We're missing the brackets here. Same thing down there. The other wing over there, it's completed. And anyway, we'll use that to tension the wing and also to set the sweep back of the wing. So no, you could build these on just some sawhorses, and that's how they were designed to do it. Part of it is the CNC, you know, so all your holes are cut, and it's just a matter of getting it correct, and then using the wires to tighten up to change the angles. And once everything's happy and fine, you nut it up and put the leading edges on. Speaking of the leading edge, explain how, well, what is used, and explain how you accomplish the curve or the D-section. Right, so on the leading edges, we use a plywood leading edge. It allows us to glue it on and make the wing be part of the wing instead of an aluminum leading edge, which is tacked on and it's not part of the wing, although it is held underneath with the fabric and held together. Gluing on a plywood leading edge just makes it a strong D-section and makes the wing stronger and less flexible and good things. So by making the plywood, we make our own plywood leading edges, and we make it out of 2 plies of 1/32 ply. Now this is the one last piece I have. We've ordered some more. It's back there. We haven't cut it yet. So I just put this up here to show it as a guide. And what I did to build my own form, I kind of looked at some other people's, and everybody's talking about building them form and vacuum forming and blah blah blah, and I just said, you know, I don't want to run a vacuum pump all day, so we're going to come up with something a little bit different, and we've got to build a bunch of these. So what I did is I used some of my experience from 40 years ago when I built a Very Easy, and we bought blue foam, we hot wire, we made a template of the airfoil, and I used a hot wire cutter, and I cut out a piece of hot wire foam, and this is actually foam from a Very Easy kit I bought from Spruce. They had it was a perfect length, and then I put 3 layers of fiberglass over the top of it. When you hot wire cut it, it burns it down just a little bit undersized, and it allowed me to put 3 layers on. And then I used peel ply, which is some old fabric or leftover fabric. We peel plied it, and then we sanded it, and the different colors are where we block sanded it, and then added a little bit of filler where it needed to be. And then once we were happy with the shape of it and the smoothness of it, then we shot some primer over it and blocked it again, and then we called it good. And then what we did to keep any epoxy drippings from sticking is we just took clear packing tape and taped over it, and so far we haven't had it stick. And then what we do is we take the plywood, we cut it to length, draw a center line on it, we put 2 holes and pop it down, and then we'll put another layer of plywood over top of it. But before we put the second layer on, we coat it with epoxy, and we have figured out that 97 grams of T88 spread on with a squeegee is the perfect amount to glue these two together. And so we'll put the two halves together, and then I have another fixture that drops over the top of it, and when we strap it down with the straps, we walk away, we come back in the next day, and we pop out a leading edge, a finished leading edge.
You showed us how that you form the leading edge, and now we've got a wing over here that the leading edge is already installed, and I kind of explained the process of that, and I see you've got some type of filler, or is that just the epoxy left over that's...
No, that's a filler. So yeah, so after we build the leading edge, we'll start in the center. The first one goes on in the center. Well, we want to have this airplane leveled. You can see my stuff here. We'll stick little shims in, and we want this wing perfect, because when we glue the D-tube on here, yes, it'll still move a little bit, but we want it as perfect because we don't want to try to introduce any twists or stresses into it. But we take our leading edge, and the first one goes on in the middle, and we let it dry. We'll put it on here. We do pull it down. If we have to, we'll put some culls in it. We've kind of figured out that sometimes when we put a cull, it'll cause it to dip a little more in places. But see, if it needs it, it needs it. And then before it dries, or once we get everything where exactly we want it, we'll go ahead and put staples, and you can kind of see where there was a staple where we started sanding. But we'll staple the leading, the trailing edges of both sides, and that just holds it in place while it dries, because epoxy, you know, sometimes it could twist around or move around while it's still liquidy and not hard, and we don't want to come back the next day and have something not in place because of stresses from the straps and pulling. So we'll go ahead and tack it with some staples just to make sure it stays there when it dries. And then once this is dry, then we'll scarf this down, and then we'll take the next piece, we'll come up to it, we'll trim it, and then we'll scarf the inside of it. Once we get it to where we like the fit and it feels pretty good, then we'll go and we'll glue the next section on so it goes all the way to here, and then the next section goes all the way to there.
So what type of wiring, if any, goes inside the wings of these?
Yeah, so this airplane we're doing, it'll probably be used for it will be used for an air show airplane, and so we've got lots of lights and maybe some smoke stuff on the end. And so what we do is we run this PEX. We buy it at Home Depot. It's a couple dollars, and it's very light, very flexible. And then we actually take and heat this up with a heat gun and bend it, and it'll let that be in a permanent bend. We'll tie it to the ribs, run it through the holes, and this gives us a place where we can run wires. If we want to change a wire, we want to change a system or how we're doing it, we can pull wires and push wires through this relatively easily without having to get inside the wing. And so it runs all the way through the wing to the outside.
All right, now for this next segment, take a look at this landing gear. See how tall it stands? It's enormous. Does this have something to do with the ground handling of this aircraft? Just good looks or something else? All right, so moving out to the project hangar, which has a bunch of other really awesome projects going on, is where you've got the landing gear stored, and I wanted to share this with everybody just to show, if nothing else, the sheer size of this landing gear, because it's not typical, and you're not a short guy. How tall are you?
I'm 6'3".
So you're 6'3". You can see him standing next to these. These are a very tall set of gear. And what is the difference between like the 6-inch smaller than the other one?
Yeah, well, they're 3 inches. Well, they're supposed to be this, because it's got some padding under there. There's 3 inches difference in the height. When Kimball did the first Model 12s, I guess, or Curtis did, they had this shorter gear, and this was, you know, what they figured they needed with the stock props. But then when they started adding engines with more horsepower led to bigger diameter propellers. Well, then they extended the gear 3 inches. And so this has actually become the standard gear, the extended gear, or which was the extended gear has now become the standard gear. It puts the airplane at a different deck angle so that when you land, you are fully stalled on the wing when you're in the 3-point. And anyway, but yeah, huge chunk of gear. When this is all laid out straight, it's 11 feet long. So it starts out as a 12-foot plat, or plank, we'll call it, of aluminum. Gets cut out and then annealed and then bent and then reheat treated. Anneal is to soften it so that they can do the bends in it. and then reheat treated back to a T6 configuration. This is 7075 is the material that's made out of.
So other than the ridiculous height on this, giving this an awesome stance on the ramp, what is the other purpose of having a long gear?
Well, prop clearance, and even still with this long a gear, the airplane is only to be taken off and landed in the 3-point configuration. So if you are to try to wheel land it, which there have been some successful ones and some unsuccessful attempts, your prop is less than 6 inches off the ground, and currently MT's wanting $26,000 for that propeller. So prop strikes, we try not to have anything. We want to stay away from that.
All right, Don, so talk to us about the specs on this thing. What are the numbers?
The numbers, okay. The airplane takes off in about 300 feet. We've proven that a time or two. It'll land in about maybe 500 feet, but you got to be a pretty good pilot to do that. It will cruise at 170 miles per hour, which is pretty good. Not in the open cockpit configuration with the bubble canopy, about 170 cruise. Red line is over 200, but and you usually get that on a downline or something. Aerobatically, it's rated at +6, -3. Of course, it'll do more than that, but +6, -3 is aerobatic category, and that's the minimum needed. The stall speed, 70 maybe, 65. With the tall gear and the stance that it sits at, as you touch down, you're at the stall speed. You will stall at touchdown, which is great because that keeps the airplane from flying and hopping. If you've got speed on it, then yes, it'll keep flying, but if you get rid of all your speed and you've 3-pointed it and you've touched down, it is not flying. It's just a matter of controlling it and keeping it going straight down the runway.
And what is the typical empty, and then what's the gross?
Typically our empty weight is around 1550, and 2750 is our gross weight. Or not 27, 2250. We have about a 700-pound useful load, which is great. I mean, that is an aerobatic useful load. So you can have 2 bodies and fuel and 700 pounds worth of it and still go out and loop, roll, tumble this airplane.
All right, now the specs that everybody's been waiting for. What is the cost of this kit, and then what is a typical cost to complete, and what are some of the options you have for getting people in the building process some help?
Okay, so the cost of the kit currently, and because I haven't changed it since I bought it, is still $75,000 for a complete kit. Pre-welded frame. Wood wings, you still have to assemble that. Anything that's welded has been done for you. If it need to be laser cut or formed, then we'll do that with our fixtures. I really need to go back and readdress it with the cost of raw materials and availability of raw materials. I do have enough to build 2 kits that are not spoken for yet as a backup, because we kind of pre-planned a little bit. All up, you could build this airplane for about $150,000. No labor, just yourself. Fabric, modest Avionics. Now, if you want the latest and greatest G3X, then it might be $10,000 more. But $150,000, no labor, would build this airplane with a current engine and propeller and paint and fabric and that kind of stuff. They sell for, I'd say there's been some sell in the 150 range. There has typically the nice ones sell in the 200 plus range, used on the used market. If you were to contract us to build one, we're probably 300, but then I got to pay labor, so about 300 for us to build you one. And we do offer building assist, so because I have a big shop, lots of equipment and tools. If you wanted to build one and have us kind of help you out a little bit, we have no problem doing that. We are doing some builder assist stuff now, minor stuff, and we're actually doing one customer. We're building one airplane for a customer currently.